So we're looking here at the ionisation energy of an atom and how it gives us evidence for shells, the shell structure of an atom. What I'd suggest you do before you listen to any of this is, first of all, to look at this worksheet from the Royal Society of Chemistry, the RSC, and also just pause this and write down for yourself what you think we mean by the ionisation energy and try and come up with a formal definition for it. So pause if you want to do that. So basically what we mean by the ionisation energy is the energy that we need to form a positive ion. Thinking about an atom in the structure that we've looked at at GCSE, you have a positive nucleus surrounded by negative electrons, and so if we're pulling away, as it were, a negative thing from a positive nucleus, it's going to require energy. So the ionisation energy is the energy required to form a positive ion, and we give it a formal definition. It's the first ionisation energy of an element is the energy required to remove one electron from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous 1+ ions. So breaking that down a little bit, it's the first ionisation energy because we're removing the first electron. It's the energy required because we're pulling something negative off of something that has a positive charge. We're removing 1 electron from each atom. We've standardised it by saying it's in a gas and that we're talking about 1 mole. And we're forming a positive ion because we're removing something with a negative charge. So the next thing I'd like you to do is pause this again and write down 3 factors that are going to affect how large this ionisation energy is. And if you can come up with 3 factors that will affect the magnitude of the ionisation energy, then try and describe why. So pause here. Good, so there are 3 factors that are going to affect the ionisation energy. If you think about it, we've got negative electrons that are held around the nucleus by their attraction to a positive nucleus. So if we're going to form a positive ion, we need to supply energy to overcome this attraction. Now, first of all, if the electron is further away from the nucleus, the positive nucleus, you'll need less energy than if it's held very tightly and very close to the positive nucleus. So the atomic radius is the first factor. The greater the atomic radius, the smaller the nuclear attraction, and so the outer electrons will be held less strongly. The second factor is the charge on the nucleus, the nuclear charge. So if you have a higher nuclear charge, a greater nuclear charge, then you're going to get a greater force holding those electrons there, and it's going to be more difficult to remove them. You'll need more energy. The third factor is electron shielding, sometimes called electron screening. Now be careful here. This isn't about electrons just kind of getting in the way of other electrons. It's about the fact that they are negatively charged in the same way that electrons outside in outer shells are negatively charged, and so they repel each other. So if inner shells of electrons repel outer shells of electrons, we call it electron shielding or screening. So if there are more inner shells of electrons, then there's going to be a larger shielding effect, and it's going to reduce the net attraction from the nucleus, which means that it will be easier to remove an electron. It will require less energy. So the 3 factors are atomic radius, nuclear charge, and electron shielding.